Hello and good evening, everyone. Welcome to the Leitner Observatory live stream for Tuesday night, public night. I'm looking here at a live view of the moon through the 12-inch telescope out on the observing deck. It's a really nice, clear, cold, bitterly cold night. Let's see, the Leitner Observatory weather station is reading 13 degrees Fahrenheit for my region. Microsoft Weather is saying it's 11 degrees Fahrenheit right now, but I'm inside. Let me turn on my camera here. There we go. Hello, everyone. Good evening. Although we're not doing in-person public observing this month for Leitner Observatory Public Night, I thought I would do some of these public live streams on Tuesday nights when it's clear, and while I'm also working on some other things. And so I have the 12-inch telescope set up outside. Thought I'd talk a little bit about what's up in the sky tonight, see if anyone has any questions about astronomy, interesting things to look at, or anything astronomy related that's been in the news. Maybe I could prove to you that this image of the moon is live video. If I zoom in enough, you'll start to see that it's shimmering due to the atmospheric turbulence. We're getting about 1 frame per second. So I'm using a new camera, actually. I don't think I've ever used this camera on the live stream before. And I'm only connected at USB 2 speed, so it's getting a little bit slow video feed. But I've got full resolution here, and you can see when I zoom in, some of the details are really quite striking. Looks like the focus might be a little bit off compared to when I first set it up, but we can work on that, try and get some images and some video. Really nice view of the moon tonight. The moon is almost directly overhead, a little bit past first quarter. I think first quarter was a few days ago. But I'll come back to this image and this video and talk a little bit about what's going on. Nice night for not being outside. Yes, I'm glad to be not outside. I've got my cup of hot chocolate. I was outside for about half an hour setting up the telescope when I first got here. I'll show you what's going on outside because, of course, I still have my my live video of the observing deck. So you can see here is the 12-inch telescope on its robotic mounts. This is a telescope we use a lot in our summer research program and sometimes for advanced student labs, along with the 16-inch telescope that we have mounted in the West Dome. So I've got a computer on a cart connected to the camera, connected to the telescope, and you see the moon's very high up in the sky. The telescope's pointed almost directly overhead, not quite directly overhead. So we'll come back and look at the moon in a minute again and point at some other nice night sky winter objects. Happy to take requests if anyone has any requests. Oh, my camera froze for a second there. A lot of electronics, the computer and the camera and the telescope like the cold weather, especially the camera really likes the cold weather. But the mount, the mechanical parts, the moving parts don't like the cold weather, and the lubricant in the gears freezes up. And so I have had mechanical problems with these mounts on really cold nights. I went to graduate school at the University of Wisconsin, and I remember observing in minus 20 degree Fahrenheit weather some nights out in the cold. But now that I'm getting older and I like warmer weather, I'm less inclined to bundle up and go out and actually look through the telescope and work when it's this cold. But I can control the telescope remotely from inside the staff office here and take images and provide a live video feed. Well, let me just talk briefly about what's up in the sky this month. And again, if anyone who's watching live has questions, feel free to type your questions in the chat. Happy to try to answer them. If anyone has any requests for particular objects you want to try to look at through the telescope, we can also try that. So here is the skymaps.com sky map for January. I've talked about this on previous live streams. I think this is a really nice free resource. Download it every month, print it out, put it on your refrigerator, highlight the dates where something happens that you might be interested in. So you go to skymaps.com download, and there's one for every month for both the northern hemisphere and the southern hemisphere and the tropics. So if we go here to January 2022, and here's the sky map for evening. So this is what the sky looks like at about 8 p.m. this time of year. Not a lot of planets. The planets will tend to line up along the ecliptic, and we see Jupiter low in the west-southwest at sunset. I saw it as I was coming into the observatory tonight. I saw it low, very bright, low in the west-southwest. But otherwise, we've lost the naked eye planets in the evening sky for a while, until I think we start to see Mars again in the late spring, and then we'll see Saturn in the late summer, and then Jupiter again in the fall. And in terms of constellations, we've got the famous winter constellations out, like Orion, right? So Orion's easy to find because of the 3 stars in the belt, the bright red star Betelgeuse at his shoulder, and the bright blue star Rigel at his foot. The 3 stars in the belt will point down to the left to the brightest star in the sky, which is Sirius, the dog star. I saw it over in the southeast tonight when I was setting up the telescope out on the observing deck. Brightest star in the sky, easy to find. You still can see some of what we think of as summer constellations, such as parts of the summer triangle. So here's the bright star Vega, very low in the northwest. Vega is at a celestial latitude of about 40 degrees. So it takes a fairly high arc across the sky, and you can see it even late into or well into the winter. At our latitude. And then Deneb, part of the constellation of Cygnus the Swan, right here. Now along Cygnus the Swan, through Cassiopeia, through Perseus, Auriga, down between Orion and Gemini, that's where the Milky Way is. Now, we can't really see the Milky Way with the light pollution that we have here in New Haven, at least with the naked eye. You can actually see it if you take a long exposure with a wide camera lens, and that's a fun project to do. You can't really see it with the naked eye here. But when I see these bright winter constellations, like what's called the winter hexagon, the winter hexagon is going to be the bright star Rigel, Sirius, Procyon, Pollux and Castor, the 2 bright stars in Gemini, make up one corner of the hexagon. Capella, Aldebaran, the bright star in Taurus, the bull, and then back to Rigel. These are very bright stars that are bright, not so much because they're close, although Sirius is only 9 light years away. They're very luminous stars, and we're looking at the inside of a spiral arm in the Milky Way galaxy, the Orion Spur spiral arm. And there's lots of evidence of star formation over in this area. There's star clusters like the Pleiades cluster and the Hyades cluster. And then there's star-forming regions that can make nebulae if they ionize the gas nearby, like the Orion Nebula. We'll take a look at the Orion Nebula with a telescope tonight. That's one of my favorite winter objects. And young star clusters, like the M35 star cluster, these star clusters here in Auriga, and so forth. So we're looking opposite the direction towards the center of the Milky Way. You see the center of the Milky Way in the summer. You see the anti-center or opposite the center in the winter. And when we're looking away from that, the central part where the bulge of the Milky Way is, we're looking at the inside of a spiral arm where there's a lot of young, bright, luminous stars. I'm going to switch over to, actually, let me see if there's anything I want to mention on the calendar, and I'll try and get out of the way of the, the calendar over here. Now it's January 11th, so we had first quarter moon on the 9th. And not a lot of interesting things happening this month, although Earth at perihelion, and that's when the Earth is closest to the sun, that was on the 4th. Maybe it's surprising that the Earth is closer to the sun in January than in the summer. Most people who are interested in astronomy know that it's not the distance to the sun that makes it hot in the summer, it's the tilt of the Earth. We're actually a little bit closer to the sun in January than we are in July, and we were closest on the 4th of January this year. Not a lot of interesting objects. Full moon is on January 17th, and a couple of moon near various planets and stars, but otherwise not that interesting. Although here we have Mercury at inferior conjunction. That means that Mercury is going to be between us and the sun, although not perfectly in line. Otherwise we would see a transit. We would see Mercury as a dot, as a shadow in front of the sun. That happens every few years, and it's kind of fun to watch if you have a solar telescope. Let's Let's see. Otherwise, not too interesting. Nothing too interesting going on. The other nice thing about the evening sky map for the month, if you print this out double-sided on a piece of paper, is you'll get a list of interesting objects that you can see with the naked eye that would be in the night sky, and that you could see with binoculars, and that you could potentially see with a telescope if you have a telescope. Some nice double stars and some fainter Messier objects like a couple of galaxies here and the Crab Nebula and so forth. Actually, maybe we'll take a look at the Crab Nebula with our telescope tonight. That is the remnant of a supernova explosion, a star that exploded about 1,000 years ago, and we see the fireball in the process of expanding. I'll take a quick look at the sky in my simulator right now. So I have Stellarium running over here in the background. This is the sky right now from New Haven. And so you can see there's the moon way up high in the sky, a little bit past last quarter, right? Just like we saw in the live image. And I'll zoom back out and take a look at the constellations. Yeah, so these are the same constellations that we were looking at in the sky map chart. Stellarium is a free program. You can download it from stellarium.org. It's very nice for learning the constellations and looking to see what's up in the sky on a given night. There's a smartphone version that you can get that you can, of course, hold your phone up and have an AR view of the sky so that you can see what you're looking at. But really nice for planning an observing session. I'm going to zoom in a little bit over here on Taurus and Orion, and a little bit of the star lore that we have going on here. Orion, of course, Orion the Hunter, a character from Greek mythology, who is going to hunt all the animals until stopped by Diana, who sent Scorpius to slay Orion. So Scorpius is a constellation opposite Orion. So as Scorpius sets, Orion rises. They're always on opposite sides of the sky. And then Taurus is a constellation in the ecliptic, or in the zodiac. So this is the path, the plane of the solar system, basically. So you see that orange line going across the sky. And we always see the sun, the moon, the naked eye planets close to that line. I don't see Jupiter up above the horizon right now. If I go a little bit back in time, you can see there's Jupiter in the sky at about 6 p.m. And if I run time forward, you see it setting at about 8 p.m. or so. So you can catch it right at sunset. Let me go back to right now. There we go. So a lot of these constellations that are in the zodiac are very old constellations, going back to ancient Mesopotamian star lore, long before Greek star lore. And there's evidence actually that Taurus is a very, very old constellation. There may be a painting of Taurus in the Lascaux cave paintings, 20, 30,000 years old. So that's actually remarkable. A lot of interesting things to look at in Taurus, such as the Pleiades cluster. We could try to look at that with a telescope, but it's a fairly big thing in the sky. Well, you can see when I was looking at the moon fit nicely in the camera field of view. And but I have the moon enlarged. That's why it looks so big. The moon is really about that big relative to the cluster, so we'd only see part of the star cluster if we took a look with our telescope. The Crab Nebula is right over here, so if I actually label the deep sky objects, there it is right there. And we could definitely try to take a picture of that. And then if we sort of scroll down here to Orion, the Great Orion Nebula. So if you sort of look at Orion here, let me hide some of this stuff. So we think of these three stars, Al-Natak, Al-Nilam, Mentaka, as the belt of Orion, and these three stars as the sword of Orion. In fact, Saif is a word that means sword in Arabic. Then if we zoom in here, you can see the middle star is kind of fuzzy, and that is in fact the Orion Nebula right there. Really nice object to look at through a medium telescope. Annular total solar eclipse October 2023. Sure. That sounds great. Yeah, I haven't looked at the eclipse schedule for next year. I'm already thinking about what to do in April of 2024 for the total solar eclipse that we'll have in the US, and trying to decide where to go. Mexico, Texas, not really sure, but yeah, annular eclipses are fun too, even though you don't get that nice totality, the view of the corona and the stars coming out and so forth. This ring of fire in the sky through your eclipse glasses. Trying to remember the last time I saw a good annular eclipse. 2012, I think I saw one in California. Okay, oops. Let's switch back to the telescope and see what's going on. All right, still looking at the moon here. And I think before we go look at some other objects, what I will do is take some pictures of the moon. Take some pictures and then I'll post links to the pictures in the description, the video description, once this live stream is published on YouTube. I'm nudging the telescope a little bit to the north and a little bit to the east. All right, and we could just zoom in and look at some of the features. A very satisfying astronomy hobby. I'm also going to tweak the focus just a little bit here. A very satisfying astronomy hobby. Yeah, that's a little better. That's getting worse. I'm going to go back the other way. You can see also the moon is drifting a little bit. And that's because I have the telescope set up right now to track at so-called star rate or sidereal rate. That's the rate of rotation of the Earth. But the moon is also orbiting the Earth, right? So as we watch it, it sort of drifts in the direction of its orbit, which is off to the east. Try to get a little bit better focus. That's actually pretty good focus, I think. So let me switch back to the video feed here, make it a little bit bigger. All right. Looks very nice. This mountain range here in the middle of the moon, this is the so-called Apennine range. Oh, as I was trying to say, I kept interrupting myself. A very satisfying hobby in astronomy is to get a moon map and take a look at the moon with your binoculars or a medium-sized telescope, a small telescope. You know, I have a $50 telescope. It's a 70-millimeter telescope, which gives great views of the moon. And just try to identify features. Just learn the different features. And you can see all sorts of interesting phenomena like the sun rising. As you see the sunlight shining on the edge of this crater right here. And the edge of this crater right here while this part is still in shadow. I'm going to up the exposure time a little bit so you can see the dark part here a little bit better. Yeah, there it comes. Now when I'm zoomed in this much, you can really start to see the shimmering of the atmosphere that we have down here at sea level. And then also something that's quite dramatic at this, so there's the Tycho crater. I recognize it from the rays coming out of it and from that sort of central mountain in the middle. As we go further south here, the south pole of the moon is very heavily cratered. It's a very old surface compared to the Maria, the darker parts that arose during the late heavy bombardment and smoothed over quite a bit of the moon. And then there aren't that many big craters in the Maria region. So when NASA was deciding where to land humans on the moon for the Apollo missions, of course, they wanted to choose relatively smooth areas. So Apollo 11 landed over here in Tranquility Sea. Right about there. That's where the Apollo 11 mission landed. Sometimes people ask me, can you see the lander? Can you see the footprints? Can you see the flag on the moon? I don't see it. That must prove that NASA never landed on the moon. Well, even with zooming in on the moon at this high resolution with this telescope, we're really only seeing details that are 10 kilometers or so across. The moon is actually pretty big and pretty far away. So you could see things from about 10 to 5 kilometers. These smallest craters that we're seeing here are probably about 5 or 6 or 7 kilometers across. And so things that are as small as the Apollo 11 landing site are not going to show up. Okay, so I want to save some images. So I think I'm going to take 100 frames here and see if I remember how to do this. Capture video. All right, we'll let that run. So to take 100, because I'm getting such slow readout here, to take 100 frames is going to take about 100 seconds. So I might not wait for that long. I'll zoom back out here so we can see sort of some bigger features. Actually, you know what I should do? I also want to adjust the exposure down again, because I'm definitely overexposing that part of the moon. Okay, that looks better. And I'm going to turn off the auto gain so it doesn't saturate it. Yeah, that looks better. Okay, so I'm going to once again save a video, and I will post this video, a link to the video in the description for this YouTube video once it's posted, so you can download this to your computer and zoom around and zoom in on certain parts of it. What should we look at next? How about the Orion Nebula? I'm going to go to my telescope control window over here, and you can see, so this is what's up in the sky right now, and there's where the telescope's pointed right now towards the moon. Yeah, I think we'll try to point at the Orion Nebula. So we take a look at where the telescope's pointed right now. Yeah, okay. We pointed a little bit west of directly overhead. So the telescope will do its flip over the mount. This is a thing where it will point north and then rotate 180 degrees and then point over in the eastern part of the sky. And that should be fine given where it is right now. So all right, so it took my video, and I think I'm ready to try to move over to Orion. So I'm going to actually stop the video readout. And once we get over there, we'll actually try pointing in the direction of Betelgeuse to start. So we'll command the telescope to move over. Now this is where I worry about something mechanical in the telescope freezing up or not liking what I'm telling it to do. But it looks like it's moving to the north. Temperature's gone down to 12 degrees Fahrenheit at the moment. Hope wherever you are, if you're watching live, that it's you're nice and cozy inside. Even if the Yale campus were open to the public, I don't know that we would want to be outside observing in the cold for a few hours. Although, you know, having lived in Wisconsin, they say there's no such thing as weather that's too cold for observing. It's just insufficient clothing, right? You got to put on your thermals, and you got to put on your snow pants and your heavy gloves and your scarf and your hat, and then you're fine. All right, looks like the telescope's working. Let's switch back to the control computer here. I'm going to come around and point at Betelgeuse first, and then we'll move just to make sure the telescope is pointed correctly. And then we will move over to the Orion Nebula, which, as I said, is down here. Jules says, could it be possible to see the Horsehead Nebula? We could definitely try that. The Horsehead Nebula is right next to the Orion Nebula. It's near the star Alnitak, but it's very faint, and we have a lot of light pollution here in New Haven. But I think, yeah, I have seen it before with telescopes here, so we could try the Orion star-forming region, the Great Orion Nebula, M42, and then we could try to take a look at the Horsehead Nebula as well. We do have a nebula filter, which could potentially block some of the light pollution, so that would be an interesting thing to try. Okay, we're going to do this live stacking mode with the camera control. And we're not going to use the full camera resolution to start. Oh, there it is. Looking good. Focus is good. So I don't really need to spend too much time here. Switch to like 0.2 of a second exposure there. Now we're starting to see the stars around Betelgeuse. It's not perfectly centered, but I think it's okay. We should be able to see the nebula. And the focus is not as good as it could be over here on the edge, but I think it's pretty good. So we can try to tune that up a little bit. So there's the bright star Betelgeuse, red supergiant, about 400 light years away, ready to go supernova any minute now. Could happen right now as we're watching. It could get really crazy bright, which would be quite amazing because it would be about as bright as the full moon when it goes supernova. So we would have this point of bright light in the sky that you would be able to see during the daytime. I don't think it's going to go supernova right now, though. So let's go to the Orion Nebula. So I think what I'll do here is type in M42, find, and we will move the telescope. There it goes, heading a little bit south. Uh, 9 Fahrenheit in North Haven, but not as cold as Finland. Well, I believe that. I believe that, Fred. Okay, let's go back to the camera and see if we see the nebula. Hey, there it is. Beautiful. Let's do some centering here. So we're going to point the telescope. Now, the telescope's flipped over, so I think what we have to do is see if this works. Nope, that's the wrong way. Let me go this way. There we go. And let's turn on the camera cooler. Now those are 0.2 of a second long exposures. This is a star forming region. Let me just do a few things here. We turn on the cooler, and it's quite cold outside. I think it would actually get, my cooler only goes down to 40 below Celsius. I think 40 below 0 Celsius. I think given that it's probably negative, 5 or so Celsius, I think it would probably get colder than that, but that's what it's stuck at. I think I'll try a longer exposure here. Let's try like a 5-second exposure. Let's do a little bit better resolution than 720p. We'll do 1440p here. And I can see the focus is a little bit off. What I might do, actually, if we're going to look at the Horsehead Nebula, is try to put our nebula filter in the way. I'm a little bit hesitant because, number one, I wonder if it's going to stay, if anything's going to break in the camera, because we haven't tried this before. And then the other thing is, I don't know how far out of focus. Well, let's see here. So we're going to switch to filter number 4. All right. And let's see what happens when we make that change. Yeah, still a little bit out of focus. So let me change the exposure time to about half a second again. And let's get that in focus here. This is sort of less interesting technical stuff you have to do when you're operating a telescope in real time, but all right. What's happening now is there's a motor that can move the camera forwards or backwards and try and get it in the right place. So that's a little better. That's too far. That's pretty good. All right, so I'm going to start taking some images here, and I'm going to try to do one of the features of this camera is that you can do a accumulated image. So we keep taking images and adding them in, adding them in, adding them in. So as you watch, the image gets better and better. So we'll do maybe a 10-second exposure and 1440p, and we'll start. The problem is I don't use this software very often, so ooh, look at that. Even the first exposure looks really nice. So I'll talk a little bit about what we're seeing here, and we'll accumulate some images. So I gotta do the start or stop stack. I have to look at the tooltips to remember how this works. Okay, I think we just click here, and we're gonna start accumulating images. This camera is not a color camera. It only, it has a sensor array built in, and it doesn't have any way of measuring the color of the light coming in. So what you have to do is put filters in front of the camera. You can do red, green, and blue, or in this case, I have what's called a hydrogen alpha filter. So that lets through the light of ionized hydrogen, which is what mostly what we're seeing here. So these four bright stars you see right here in the middle, this is a star called Theta Orionis, or the trapezium cluster. It has other names as well. And these are O stars, very, very hot, massive young stars that have recently formed from a star-forming nebula, or a star formation region right here in this area. They're putting out a lot of ultraviolet radiation, and that will ionize, rip off the electron of the hydrogen that's floating nearby, and make it fluoresce just like a neon sign. So this is a big hydrogen sign saying, "Eat at Joe's," saying stars are forming right here. Now, where you have star formation, you also tend to have a lot of dust, and so we're seeing kind of the shadow of dust clouds in silhouette in front of this emission cloud. Now, let's see, how's it looking? Yeah, so I'm not sure how well this will come through in YouTube, but this is one 10-second exposure, and this is the combined, let's see, 11 exposures. And you see it's a little bit less fuzzy. Let me zoom in here. This is looking like a really nice image. This object is also fairly high in the sky, so. Not color, right? But this would all be red. This is only letting through a very specific red color of light. And when you see images of the Orion Nebula, it has this kind of purplish, whitish, reddish glow to it, and that's because of the hydrogen emission. Yeah, this is looking really nice. I think maybe what I'll do is get a few more images and then save the image. And I have another nebula filter, and I wonder if it would be in focus. Because what you can do is actually combine different color filters and get a colorful image, even if it's not true color. So let's go ahead and save this. So yeah, this is good. So I'll make a new folder for myself here. Okay, right? That's saved. And it's still accumulating. I'm going to try something here. I'm going to try switching to the... So first of all, I'm actually going to clear out that image. And then I'm going to try switching to the other nebula filter and see how it looks. So it'll take a few seconds to deal with that switch. It's out of focus. All right, I think I'm not going to try to get it in focus right now for you. I'm going to go back to the other nebula filter and go to the Horsehead Nebula because I think we'll get a better view. It would take me a couple of hours to get this in focus and take some nice images. I might do that off camera so that I have a nice image I can post a link to in the video description, showing the hydrogen alpha and the ionized oxygen image together. Okay, we're back to the other nebula filter, and so it looks like it's a little bit out of focus again. The telescope focus is a little bit fussy tonight. I'm not sure if that's the cold or what, but really beautiful star-forming region and some lovely high-mass stars in the middle there, the trapezium cluster. You can see this object with the naked eye. It's bright enough. You can go out and see it if the sky's dark. If you have a pair of binoculars and you look at the sword of Orion, you'll see this fuzzy patch in the middle of the sword. And then if you have a smaller, a medium telescope, like a 90 millimeter telescope or a 6-inch or an 8-inch telescope, you can really see a lot of detail in this object, and you can see the star cluster, the 4 little stars in the middle of the star cluster. So a big favorite on Tuesday nights at the observatory when it's clear. All right, let's go to the Horsehead Nebula. So again, I'm going to just look for it in the database here. There it is. It's very close to that bright star. Let's move the telescope up there. You see the stars streak as the telescope moves. Okay, nothing there. Well, let's do the track and accumulate here. Let's also try a longer exposure. We'll do 30-second exposures. The readout is down here, so we can see how far along we are in the current image. All right, can you see that little silhouette right there? All right, let's start accumulating images here. So this is what's called the Horsehead Nebula. It's very faint, and what we're actually seeing is a ionized hydrogen cloud that's behind a little bit of a finger of dust that's kind of sticking out. So not sure how clear it is on YouTube, but just a little bit of a shape right there. Okay, there's the second image combined in. Let's do, the focus isn't perfect, but I think it's good enough to see what's going to come out of the out of the noise. Let's try to save up maybe 5 or 6 images here. Okay. I can also adjust the brightness and contrast a little bit. Maybe it might be a little bit easier to see if I make some adjustments. There we go. There's the horse's head right there. There's the hydrogen emission around it. The Horsehead Nebula is pretty much impossible to see with your eye to the eyepiece of a telescope. It's a photographic target. You really need to have a medium-sized telescope Although if you zoom out with a smaller telescope, you can still see it if you take a long enough exposure. The image on YouTube is clear. Oh, good. You never know with the compression how much detail you're going to see. You can see if I switch back and forth between the accumulated image right there. This is 5 images stacked right there, and that's the last single image. You can see it really starting to come out. Yeah, that's pretty good. Meredith is asking, is the Triangulum galaxy visible currently? I think so. Let's go look at Stellarium, or actually what we can do is go look at telescope control. Triangulum is M33. It's over on the other side of the meridian, and it's going to be right in here. It's bigger angular size, but we could try to take, there it is right there. Yeah, I have a request for M33, the Triangulum galaxy. We can definitely try for that. Although it is a little bit close to the moon. You see there's you see where the moon is right there compared to where the Triangulum galaxy is right about there. And the nebula filter doesn't help you with a galaxy, although the Triangulum galaxy does have a lot of star formation regions in it, like the Orion Nebula, and they show up as kind of isolated patches of light when you use a nebula filter to take a picture of it. So it's kind of an interesting project. Sometimes I have students do this, take a picture of a galaxy with no filter so you see where the stars are, and then take a picture with a nebula filter and look at, overlap them, and that lets you see where the star forming regions are, and those line up really nicely with the spiral arms. Yeah, all right, let's see how many images we have accumulated on the Horsehead. Hey, so that's 8 stacked images, the equivalent of about a 4-minute exposure. Not a very long exposure. If you were really trying to make a nice, pretty picture of the Horsehead Nebula color that you're going to post on Astrobin or on your website, your social media site or whatever, you'd probably want to spend a couple of hours taking images, accumulating light from the Horsehead Nebula. But I think that shows it fairly well right there. So let's be sure to save this. I'm going to stop the readout, and I am going to save this image. Did it save? It did. Okay. And let's go look at the Triangulum galaxy. So we'll clear that. And it might be a good idea, again, to look at something nearby. 33. Let's just go for it. Let's just swing the telescope around. Is there anything else we want to see over on this side of the sky? It's 8:40. I think we'll go over to the Triangulum galaxy and take some pictures, and then I'll stop the live stream for tonight. So let's swing over the telescope. There it goes. It's going to point north and then turn over and then point south again. And we can see it in the live video. There it goes. We're down to 12 degrees Fahrenheit outside, getting colder. I will bundle up when I go outside in an hour or so to take down the telescope, put away the computer. At least the observing deck is not, and the parking lot here is not very AC. We had a warm day on Sunday that melted a lot of the snow and didn't leave a lot of water to freeze and create icy patches. Okay, let's we're getting there. Those are the images that I took today. We'll switch back to maybe like a 2-second exposure to see what's there. Oh, you know what? I should I'm going to have to refocus for a different filter, so we'll do that when we need to in a minute here. All right, we're swinging through the Andromeda constellation right there. The Andromeda galaxy is right about there. And there is M33, the Triangulum galaxy. I think this is the one that's called the Pinwheel. So let's see what's there. We're going to switch to a green filter. And hey, okay, so we're going to need to do some focusing here. So that should be job number 1. All right, so see some faint stars in there. Hopefully this won't take too long to get them more or less in focus. So go to the focuser. A lot of professional observatories and advanced amateur observatories will have autofocus systems so that you don't actually have to do this. It will jump right to the focus point. But since we're a teaching observatory, I like to have the students do this. Hey, I'm getting there. I see some stars coming through. All right, that looks pretty good. Okay. Oh, all right, let's take some long exposures. I think the galaxy might be over here. So we'll start doing, again, 30-second exposures. And I might turn on some binning here to get a little better signal to noise. All right, here comes the first image, long exposure. 6, 5, 4, 3, 2, 1. Oh, image size is not actually. What did I do wrong here? Image size. Oh, because I changed the binning. Oh, that's okay. That's okay. It just didn't. It didn't like that first. Yeah. So we got to clear. Yeah. Okay. All right. Okay, that's all fine. Okay. Try again. Okay, I see the galaxy a bit. Let's actually nudge the telescope. There's the center of the galaxy right there, and there's some of the spiral arms. The whole galaxy is not going to fit in the field of view of the camera, so maybe actually I'll leave it where it is, and we'll see kind of this half of the galaxy in the center of the galaxy. Okay, and again we'll accumulate a few images to get a better signal to noise, and then we'll try and adjust the brightness and contrast to get it to look really nice. Nice galaxy, big galaxy in the sky, one of the closest to the Milky Way, second closest big galaxy to the Milky Way. So the Andromeda galaxy, M31, is the closest really big galaxy. It's a little bit bigger than the Milky Way. M33 is smaller than the Milky Way. It's maybe a third the mass of the Milky Way. And we see it face on instead of kind of at a tilt like we do with the Andromeda galaxy. And it's an SC galaxy, so it has open spiral arms with a lot of star formation and a relatively small central region. These stars that you see, these points of light, are all in the Milky Way. They're foreground stars. And then this kind of fuzzy light that's in the background, that's all from the galaxy. We got 4 images accumulated. Let's play with the brightness and contrast here a little bit. Yeah. Looks like a nice image. A little bit hard to see it as a galaxy, although I am seeing some dust lanes sort of over here near the central part of the galaxy. But not a bad image for just, 3 or 4 minutes of exposure time. Again, you'd want to do an hour or 2 hours or 3 hours of exposure if you wanted to make a nice high quality image for astrophotography. All right, well, I will take a few more exposures here and then save the image, and I will put that in the video description so that you can take a look at the image later on, tomorrow sometime. And I think I might, if I have time, if I can get it done within half an hour to 45 minutes, go back to the Orion Nebula and take some images through the other nebula filter to make a false color image. I think that would be fun. And so I'm gonna work for another half hour to 45 minutes or so here, and then bundle up and go outside and put away the telescope. So I hope everyone is doing well. I encourage you to get your binoculars, put on your down coat, go outside sometime this winter when it's clear, enjoy the night sky, take a look at the Orion Nebula through your binoculars, scan the Milky Way, find some of these star clusters that look really nice in the winter, and enjoy the winter sky, beautiful winter sky. I'm not sure if we're going to do these live streams every Tuesday night. Probably over the next month when it's clear, we'll do them. Expecting that by next month, by February, Yale campus will be more open and we can start doing the outdoor public observing sessions on Tuesday nights. So if you're in Connecticut, in New Haven, nearby, you can check our Twitter feed, which is twitter.com/LFOP, or our Facebook page, Leitner Observatory on Facebook, or our main website, which is leitnerobservatory.yale.edu. And that's where we make announcements about events that are happening when we're opening to the public again, and so forth. Hey, this image is starting to look really good. I can really see some of those patches of light in the spiral arms. Yeah, this stretch looks nice. So I can see there's a spiral arm, there's the center of the galaxy. Yeah, looks pretty good. All right, my name is Michael Faison. If anyone has any questions, you can send me an email, michael.faison, Faison, @yale.edu, and happy to answer your questions. Otherwise, clear skies, everyone, and best wishes. See you next time. Bye.